everyone. So as promised, we are doing a review of systems of equations. So systems of equations, or actually systems of linear equations. And just as a kind of a reminder, a system of equations is a method for solving two linear equations to find their points of intersection. So systems, if you're solving a system, you're actually looking for the point of intersection of two lines. Okay? Now, we've been talking about intersection in geometry, so that's really important. But there's a couple other things that can also happen with a system. The lines could actually not intersect at all, which would mean that they're parallel lines. Okay? And it could work out that the lines actually are the exact same line, which means that they have infinite places they intersect. So those are just a couple things to keep in mind. But if we want to solve a system, the two ways that you learned were either by substitution or elimination. Looking at this first example, I never would have used substitution. I only want to substitute if like one of the coefficients, so the numbers in front of the variables, is a 1. So in this case, I'm going to use elimination. Sometimes your teacher might have called it linear combination. When I do that, I want to look for the variables that are the same number, same coefficient, but opposite signs, or I want to at least make them opposite signs. And I see that the x's, I can easily make 4s and make them opposite signs. So I'm going to multiply the bottom equation by a -2. All right. Now, I'm really neat about this because I am going to rewrite my equations when I do that. I don't want to be messy with a system. It's very easy to make a mistake with all those variables hanging out there. All right, so we get -4x plus 10y equals 34. All right, so now the systems are ready for you to eliminate. Eliminate really means add them together. So I'm going to add them together. And notice I put the line there. It reminds me of how I do addition. I do it vertically. So a 4 and a -4 are going to cancel, get eliminated. 3y plus 10y gives me 13y. And then 5 plus 34 gives me 39. Okay, so then I divide both sides by 13. And I get that y is equal to 3. Now, I'm not finished yet because remember, we're looking for a point of intersection, which means a coordinate point, an x and a y, since they're two lines, and lines we graph in the coordinate plane. So I'm going to take that y, I'm going to go to either one of the original equations. The first one looks a little bit easier for me. So let me start that over. 4x plus, I'm going to substitute that 3 I got in, and I'm going to get 4x plus 9 equals 5. All right, so then I'm going to subtract 9, and I'll get 4x equals -4, and then divide by 4. So x equals -1. All right, so the coordinate point where these two equations are equal is at the point 1, 3. Now, I'm going to check that. So the best place for you guys to check this is by using Desmos. So I'm going to get Desmos up for us. Okay, and that's that graphing thing that we use. I'm going to put the lines in. I can put them in directly as they're written. There's 1, and there's 2x minus 5y equals -17. And I see here that the coordinate point is indeed -1, 3. You see that point of intersection nice and clear. So I definitely want you to try and use Desmos to help you check. All right, guys, I hope that helped as a reminder for systems of equations. And have a great night.